Okay, so for today's lesson, we're going to combine a whole bunch of um, exponents into one lesson. So exponents, you've definitely had exposure this year. You've definitely had some exposure last year. So there are lots of different rules that you can follow. I'm not always one that necessarily follows the rules per se, but I like to kind of do it as a more common sense approach. So if you've got a product of powers, if you've got bases that are the same, and then you've got two different powers. Essentially, all you're doing is adding the powers together. In other words, if I've got x squared, I've got two x's coming from that. If I've got x cubed, I've got three x's coming from that. Well, because the bases are the same, I can just add my powers for x to the fifth. If I've got a product of powers, if I've got an exponent raised to an exponent, the shortcut says I can just multiply them together. So that's pretty simple. 4 times 3 just becomes x to the 12th. What I like to do for ones like this is I say, well, my outside power is a 3. Essentially, what that means is I've got x to the third, I've got 3 parentheses, whoopsie, not in the right spot. I've got 3 parentheses, right, my outside power, of x to the fourth in each of them. And then I go back to the beginning. Well, if I've got 4 x's from my first, 4 more, which is 8, and 4 more, that's 12. So whether you want to write it out or you want to do the shortcut, that's entirely your choice. A power of a product. If I've got an outside power and I've got two things being multiplied together inside, essentially it's just like the distributive property. Distribute your power to the other powers. In other words, that's x to the first, that's y to the first. If I multiply x to the first times 1, I get x to the fourth, and y to the fourth times 1, I get y to the fourth. In other words, what that's saying is I've got 4 parentheses. Each of them have x and y in them. And if I look across, I've got 4 x's and 4 y's, x to the fourth, y to the fourth. The last one is very similar. It's saying that now you've got exponents inside and outside. Essentially, it's a distributive property all over again. So x squared to the fourth, power times power, x to the eighth. Y cubed to the fourth, power to a power, or y to the 12th. Again, I'm a big fan of saying, well, you know what? I've got 4 parentheses. Each parenthesis has x squared, y cubed, x squared, y cubed, x squared, y cubed. Essentially, there's 2, 4, 6, 8 x's, 3, 6, 9, 12 y's. And that's where that's coming from. So those are all the multiplication pieces. We also have power rules with division. And the rules basically say, well, if my top value m, I'm going to go to the rules first and then tell you what I like to do instead. But if my top value is greater than my bottom value, but the bases are the same, all I have to do is subtract the powers. What I like to say here is, okay, I've got x to the 7th over x to the 3rd. They're giving me a fraction. I'm probably going to end up with a fraction. Well, where are there more x's? And there's more up top. How many more up top? Well, if there's 7 up top and 3 on the bottom, there's more on the top by 4, which means all the x's on the bottom went away. Essentially, I could put it over a 1, or I don't have to put it over anything. What this is really saying is if I have 7 x's, and I have 3 x's, anytime I divide an x by itself, I get 1. X by itself, I get 1. X by itself, I get 1. I've got 4 x's left on top, or x to the fourth. If we apply that same rule for this next one and we say, okay, well now I've got a fraction again, I'll give myself a fraction bar. Where are there more y's, top or bottom? The answer would be, well, there's more y's on the bottom and there's more y's by 3 on the bottom. Well, I have nothing left on top. So what does that mean that I have to do? And that means I just have to make sure that I put 1. So it's 1 over y to the 3rd. Let me just check something because I feel as though, okay, didn't know if I was still recording or not. Okay, so if m is less than n, then the rule says, okay, it's 1 over a to the n minus m. I'm not a big fan of the rules. I like to say, where are there more, top or bottom? That's where they stay, and how many more? So this next one is, well, they're equal on top and bottom. And we could say, well, if I had 4 z's on the top and 4z's on the bottom, and I divided, well, z divided by z is 1, z divided by z is 1, 1 and 1. This comes out to be anything divided by itself, which I think you know already is just 1. So if you've got powers that are the same, and we're dealing again with subtraction, the deal is that you would do m minus n, which would be 0, and this takes us to a property on the next page where anything to the power of 0 is 1. Remember, don't forget things that you know already. 5 divided by itself is 1. Negative 2 divided by itself is 1. Z to the fourth divided by itself is also just 1. When you've got negative exponents and zero exponents, the zero exponents is something that I can show you what happens, but anything to the power of 0 is 1. So 5 to the 0 is just 1. And that essentially is something that you could sort of see on your calculator. If we just clear this up, if I just put anything, 8 to the power of 0, I'm going to get a 1. If I use like a negative number, remember negative numbers should go in parentheses, negative 3 to the power of 0, that's going to be a 1 also. And that essentially comes from if you were to take any number and keep dividing by the same thing over and over again, you never get an answer of 0. For example, like 2 to the fourth power, we know, and maybe you don't, but you probably do, is 16. If I divide 16 by 2, I'm going to get 8. And that essentially means that 2 to the third power is just 8. And if I divide by 2 again, that's 4. But isn't 2 squared just 4? And then if I divide 4 by 2 again, divide it in half again, I get 2 to the first power. And 2 to the first power is just 2 because 4 divided by 2 is 2. But then when I divide by 2 again, I'm going to get 1. And if I think about that power, if I deal with something like this, y equals, I'm going to go down here, 2 to the power of x. And I go to the table of values, you can see what's happening, right? So if I've got 2 to the fourth power, whoopsie. So 2 to the fourth power is 16. 2 to the third is 8. 2 to the second is 4. 2 to the first is 2. 2 to the 0 is 1. And then 2 to the negative 1 is a half. And then 2 to the negative 2 is a quarter. And hopefully you notice that this, which is really a half, is the reciprocal of this. This, which is really a quarter, is a reciprocal of 2 to the second. So let's kind of go back. It's a little bit easier maybe to see here. When there's negative exponents, wherever the negative exponent is, the way to make the negative exponent positive is to actually flip its position, is to actually define the reciprocal. So if I've got a to the negative n, then what I'm going to do is I'm going to flip out, and I'm going to take my exponent, that's negative, with my base, I'm going to flip it to the bottom since it's on the top. And then once I flip it, my negative exponent turns into a positive exponent. So what that means here is I've got y to the negative third up top. To make it positive, I bring it to the bottom. It's like the reciprocal. So you're really just finding reciprocals. If your negative exponent's in the denominator and you move it up to the top, it becomes positive and you've made the reciprocal. And that's what's happening in this next piece. If I take z to the negative fourth and move it to the numerator, once I move it, then I out the negative exponent, and now I've got z to the positive fourth. So negative exponents are really just reciprocals. I think when you see it in a problem, it's going to make a lot more sense. Okay, so we're going to simplify all of these. Answers must be expressed with positive exponents. So I've got 3a to the 6th and multiply by 1a to the 8th. 3 times 1 is 3. A to the 6th and a to the 8th, total a to the 14th. You're adding those exponents. On the next one, if I just deal with each piece separately, 8 times negative 1/2 is just negative 4. I've got x to the first and x to the second, which totals x to the third. Bases are the same, add the exponents. Y cubed and y to the second is y to the fifth. And that would be your final answer. When I look at number 3, I can totally distribute the powers, but you need to realize it becomes 6 squared, b to the 4 times 2, and y to the 1 times 2. That becomes 36b to the 8th y squared. What I probably would prefer to see you guys do is say, you know what? I've got 2 parentheses. Each of them has 6b4y, which means 6 times 6, 36. B4, B4, B8, Y1, Y1, Y2. Number 4, no negative exponents, but I have a fraction. I might end up with a fraction. There are more b's on top by 3. There are more c's on top by 3. I don't have a denominator. I could put a 1, but I don't need it. Number 5, no negative exponents. So let's take this thing piece by piece. If I look at just my numbers, negative 9 and negative 18 is negative a half. H's are more on the bottom by 3. J's are only on the bottom by 3. K's are the same. They cancel out, become a 1, and there's no reason to include a K. There's your final answer, negative 1 over 2H3J3. On this next one, there is nothing on the top in terms of an outside exponent, but on the bottom, I've got 2 parentheses with 6A3 twice. So what I would end up doing is saying, okay, well, on my bottom, I've got 6 times 6, 36, a cubed, a to the 6th. On the top, 3 times 2 is 6, a5 and a4 is a9. Now I'm going to be able to simplify this, and I'm going to say, okay, well, 6 out of 36 is just 1/6, and there are more a's on the top by 3. And let's go on to the next one. This one now has a negative exponent. If I do with negative exponents always as flipping out, I would say I've got 3 to the negative 4. I have to make negative exponents positive. What that means is I've got a fraction where 3 to the 7th was not circled because there was no negative exponent, but 3 to the negative 4 has to turn into its reciprocal, 3 to the positive 4 on the bottom. Well, I'm dealing in base 3. Where are there more 3's? More 3's on top by 3. That's my final answer. Just understand that 3 cubed is 27, and the Regents could give you the answer either way. On the top, I've got 4x3y2 twice. On the bottom, I've got 2xy3 3 times. And it does take a little bit, whoopsie, it does take a little extra time to write it all out, but I think you're less likely to make a mistake by writing it all out. 2xy, there we go. And that's your bottom. If I try to now combine everything that I have, on the top, 4 times 4, 16, x to the 6th, y to the 4th. On the bottom, 2 times 2 times 2 is 8. X's total to 3. Y total to 3, 6, 9. If I simplify this, 16 divided by 8 is 2. 2 over 1 is fine. There's more x's on top by 3. There are more y's on the bottom by 5. So this final answer should be 2x to the 3rd over y to the 5th. Number 9, I'm going to put this over a 1. Both of these are negative exponents, so both of these have to move. So when I go back to my fraction, I know A has to drop to the bottom and become a positive 2. B has to drop to the bottom and become a positive 4. Nothing else is there, but I can't leave just a fraction with a denominator alone, which means it's 1 over. It's kind of like doing something like this. If I had 5/10, 5/10 is not 2 wholes. 5/10 is 2 on the bottom, but 1/2. On number 10, because I've got negative exponents and power to power, I think the best thing to do here is, because I can't write out exponents negative times or parentheses negative times, will be to use your power to power rule. Negative 3 times 2 equals negative 6. Negative 6 times negative 1 equals positive 6. Then I would say, okay, I've got some negative exponents here. This thing has to move. So what doesn't move is the one that wasn't circled. What does move is the one with the negative exponent. But anything divided by itself just turns into one whole. Two more to go. This one has just got negative exponents, so I'm only going to circle what has to move. X to the negative 2, z to the negative 3, x to the negative 5, and y to the negative 2. What doesn't move, it's kind of hard to see, but look at your paper. So 12 on the top doesn't move, 4 on the bottom doesn't move. There's a y7 that we didn't circle on the top and a z2 that we didn't circle on the bottom. But what does get circled moves position, basically becomes like the reciprocal. So on the bottom, I have to take that x squared. It was x negative 2 up top. It's x positive 2 on the bottom. Z negative 3 up top becomes z positive 3 on the bottom. On the bottom, x negative 5 moves to the top and becomes x positive 5. And y negative 2 on the bottom moves to the top and becomes y positive 2. If you want to tighten this up, you definitely can. So if I tighten up the top, I've got 12. There's 9 of the y's, y to the 9th, x to the 5th. Alphabetical order does not matter. On the bottom, there's 4. There's z to the 5th, and there's x to the 2nd. So now we need to simplify. Well, 12 divided by 4 is just 3 over 1. The 1's not necessary. There's only y's on the top, so they all stay there. There's x's in both positions, but there's more x's on top by 3. And there's only z's in the bottom, so z to the 5th has to stay there. So 3, y9, x3 over 1 z to the 5th. Last but not least for this one, again, what I'm going to do is I'm going to multiply the powers in, and then we'll show you how we work with that. So this becomes 2 to the 2nd, which is 4. Negative 4 times 2, negative 8. 2 times 1 becomes y squared. 3 squared is 9. Negative 3 times 2 is x negative 6. Negative 2 times 2 is y negative 4. And 1 times 2 is z squared. Again, where are their negative exponents? Just here, x negative 8. Here, x negative 6, and here, y negative 4. So what doesn't move? On top, 4y squared. What doesn't move on the bottom? 9z squared. What now has to jump to the bottom? X negative 8. The reciprocal becomes x to the positive 8 on the bottom. X negative 6 goes to the top of x6. Y negative 4 bottom becomes y positive 4 on top. If I want to tighten this up, I'm going to get 4y6, x6. On the bottom, it's just 9, x8, z2. I switched that order. That's okay. And then in terms of simplifying, 4 and 9 don't simplify. Y's are only up top with 6. X's are top and bottom, but more on the bottom by 2. And z's are only on the bottom by 2. Okay, so a lot of stuff happening in one lesson. Okay, so you've got some 6 problems or so to do for homework. Some have actually most have negative exponents. All right, so we will see what happens tomorrow. All righty.